I chose this word code to cloud because I think we use cloud, we use in different terminologies, but at the end of the day, it's all about delivering applications, delivering infrastructure, delivering capabilities, and this motion has changed in the last years, and with it, the attacker's motion. And what I'm going to talk about today is basically what we see as the hottest trend in the last year or two in terms of breaches, which is all around this, touching all the different parts of this code to cloud. And so I want to start with this statement. The adversaries are targeting our code to cloud infrastructure. So it's no longer just the cloud, right? When cloud attacks started, people went after your AWS, right? I think it was 3 years ago, it was called the year of misconfigurations. But now it's everything along this path. So from the development environments through the cloud identity providers, data providers, and so on and so on. And the reason they do it is because this is a generalized infrastructure, meaning everybody uses pretty much the same tools, capabilities, of course not the same, but in groups. And it means that when I find a way to breach something, it immediately becomes scalable. We see a lot fewer very targeted single target attacks and a lot more campaigns that leverage something against an infrastructure. So it's scalable and efficient, definitely more scalable and efficient than looking for vulnerabilities in custom code, but also more efficient in many ways than targeting highly monitored infrastructure. And because we got much better with workload security, even Kubernetes security has become better in the last years, targeting the cloud services themselves is becoming a much more lucrative area. So for those who don't know me, Ofer Maor, CTO and founder of Mitiga. I've been doing cybersecurity for 30 years, a lot of it in the prevention space, application security. And about 5 years ago, I switched to the response side. And I did it because, well, you have to. We see that prevention is not going to actually help us eliminate breaches completely. And part of what we do is help reduce the impact by preparing in advance. And I think it's very, very important as we see that breaches are inevitable. And I'll talk more about it in my other talk. So I want to start with this statistic. And this is a very important statistic. So only 1/3 of the breaches that people have are actually discovered by the organization, right? So that means 2 out of 3 of the times when you read about a breach, actually when you read about it, it's a little bit more than that because some of the breaches people manage not to get to the press. But 2 out of 3 times when an organization discovers a major data breach, they didn't discover it themselves. So who discovered it? Either a ransom note or a notification from some police agency or a third party that told them about them, or everything in the news. And so why is that important? It's important because it means not only our prevention is not 100%, but our detection is also very far from being 100%. And you know why? Because if our detection was good, you wouldn't get to that big breach. So when your detection is working, it's great. You don't get here. But when it fails, you get the big breach. And so I want to start with this. This is one of the most interesting stories of the last few weeks, the Snowflake breach. And just to get things out of order, Snowflake wasn't breached, right? At least to the best of our knowledge and everything published around it. But Snowflake customers were breached in the hundreds. There are at least 165 confirmed. There are probably more than that. And this was a very, very interesting story because it didn't actually breach anything in Snowflake, but it used weaknesses in default settings that have been around there for a very long time. And the only reason it got breached now is because some attacker said, well, you know, AWS is already more secure. Let's find what else we can look for in the chain, right? And so they built a tool to go after Snowflake customers. No one specific in mind, just let's go after that. And so what did they do? They started by developing what they needed to do that, right? So there's a tool It's called Rapeflake, excuse the language. It's an automated tool that scans Snowflake instances looking for the right tenants and uses credentials it got from other places to try and see if it can log in. Nothing fancy. Why does all this work? All this works is because by default, Snowflake doesn't do MFA. If you have Snowflake, you have no MFA by default. Even worse, if you're an admin of a Snowflake instance, you cannot enforce MFA. You have to go to every user in the org that uses Snowflake and say, oh, can you please turn on MFA? Yes, it's very important. And if they do it, great. And if they don't, well, no. You can't block them. You can't do anything. So that's what they did. They discovered this weakness in a default environment. They went and they just got credentials from info stealers. And these info stealers didn't attack Snowflake customers. They were just generic info stealers running. So when you go home and you log in from your home computer to your work, which you shouldn't do, you create a new risk. Later, your kid puts something on that machine. It gets infected. You get malware. They steal your credentials. And the price of info stealers of credential data is on the rise because this is now the main target for attacks. So they got that, they got the tool, and basically they just started running it, brute forcing instances, credentials they stole, and they got to hundreds of customers. And then for each one of those, they just started siphoning the data. There is no anomaly detection, there's almost no security controls. And they were able to download data, and if you've heard, Ticketmaster, Santander, Auto Parts USA, there's a bunch of others. I can't remember everybody's name at this point. But big breaches, some paid ransom, so we don't hear about. A lot of them didn't, so the data is already on sale on the dark web. And this is how it looks. And if you're a Snowflake customer and you hear about it, right? This broke out in the news 2 weeks ago, 3 weeks ago, something like that. There isn't really, it's not a vulnerability, right? It's not like, oh, I'll put this patch and I'll see this signature if somebody used it. No, again, it's just using credentials. So what you need to do at this point is start hunting on whether maybe somebody did something that looks suspicious in my environment. And that's what we help customers do, but that's what everybody, if you look at all the vendors in our space, everybody's published a hunting guide for Snowflake. Why? Because this is what you can do. And it's very challenging, especially if you consider that Snowflake logs are in SQL, and security people don't know SQL, generally speaking. And so it makes it challenging. So, looking for things that go beyond IOCs. Why? Because IOCs change very quickly, right? The day this was published, it was published with, oh, the attacker is using so-and-so VPN. As you can imagine, an hour later, the attacker moved to another VPN. IOC, dead. You have to look at the behavior. And you need to have the data for it. If you don't have logs, you have nothing to hunt on. And so I think the biggest and most important thing that we're seeing right now is adversaries no longer break in. They log in. There's this cliche, identity is the new perimeter. I can't stand saying it anymore because it's been so abused, but it is the reality. We are using identity as a single form of access across our entire code to cloud infrastructure, and that gets used. And the fact that you have MFA only makes it a little harder because MFA can be circumvented too, and we see that all the time. And so this is now more than 50% by some statistics for what we see. Again, we're biased, right, because we do cloud IR around these areas, but what we see, it's over 75%. So this is from IBM's study on cost of data breach, and here you can see stolen, compromised credentials, phishing are the two biggest impacts for breaches, and that's across everything, not just cloud. And again, it's over 50% of initial access vector. And so if there's one thing where you need to get better, is in identity security. And if there's one thing you need to get better in detection and response, is figuring out when identities are compromised. And it's hard because it's not a vulnerability. It's an identity being used, supposedly legitimate. Every activity later seems legit. And so what we see attackers go, they hijack a single sign-on identity, they go to your portal, and then they get everything. This is your code to cloud infrastructure, right? It's all single sign-on. Why is it all single sign-on? Because we, the security industry, told everybody that this is more secure, right? And it is more secure because the Snowflake breach is a good example where single sign-on is not enforced. But then this becomes a new entry point. And we see attackers go with MFA circumvention techniques all day long, breaching accounts, going in. It's amazing when you do incident response to something like this. You just see them go to the portal, Okta portal, Azure AD portal, whatever, one app after the other, clicking, 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 seeing what they can access. And then they download data. So I want to tell you a story about another way to get access keys and credentials. So this is the story of Sisense. Everybody here knows who Sisense are? Who knows Sisense? Okay, not a lot. So Sisense is an Israeli tech company, unicorn, does great work in data analytics, very, very impressive company. They connect to organizations, collect a lot of data, and do BI on this, right? This was released 2 months ago by CISA as a warning that they were breached. And again, if you look here at the bottom, what are they saying? You should investigate and report back any suspicious activity. Why? Because through Sisense, they got access keys. I'll explain in a minute how. And then from this point, if you're a Sisense customer and your access key got compromised, again, no signatures, no IOCs, no alerts, just trying to figure out if somebody used what looks like legitimate access going after your environment. So how did this Sisense breach happen? Because they suffered the same thing that now their customers are potentially going to suffer. So it all started with an attacker that compromised a single GitLab account of a Sisense employee. We don't know how that happened, but somehow took over that account. Supposedly credential theft. That's the highest probability. Then he found secrets in the code. Now I know you all think to yourselves, we don't have secrets in our code. We manage that properly, which is of course true, but also false at the same time, because nobody manages that correctly. And then they found secrets. The secrets led to this really, really fantastic bucket on S3 that had all the customer data in it, like terabytes of data, but also millions of secrets, because the way Sisense work is they connect to your environment to collect data, so they kept all the secrets they needed in clear text, not encrypted, not in a key management, in the bucket, which we can have a discussion on how great that is. And then the attacker took that and then started going after Sisense customers, one by one. And that's why CISA issued this warning. But basically, at this point, CISA is saying, well, if you're using Sisense, you should rotate all the keys that you ever gave to Sisense. Do you know what are all the keys? And then, of course, figure if you've already been compromised. And so these things are extremely challenging. And this is how breaches look today. And that's why our detection systems don't find them out, because you just connect with a user. And usually they'll use some cloud infrastructure to connect to you. So it's not going to be a suspicious IP. It will be maybe an AWS IP. It's all legit, right? And so, and this is just another one from a few days ago, published by Datadog. Again, another campaign using supposedly info stealers. Again, this is still in investigation, but collecting secrets to AWS buckets and vaults and brute forcing them. It's a slightly crude campaign. So there are IOCs. It's using pretty standardized IOCs. But it's amazing. We saw that. We ran a hunt the same night on these IOCs across all our customers, and we found a couple of hits. So it's crude, but wide. And so it's, again, going after just things that are in the services, just using credentials. No fancy thing, no exploits, no vulnerabilities, just credentials. And it's easy. You don't even need to be the person who knows how to collect the credentials, because there's a whole industry of info stealers. You just buy the credentials, and then you go after these cloud infrastructures, services. And then, pushing left in the code to cloud, what we're also seeing is a lot of targeting of the dev infrastructure itself, right? So the dev infrastructure moved to the cloud. Some people call it SaaS, some people call it cloud. I don't care what it's called, but it's in the public cloud, not behind a firewall, not managed by us, right? GitHub, GitLab, CI/CD, whatever you use, Atlassian, Circle CI, it's all a SaaS service. Some of these vendors are discontinuing their on-prem versions, which makes sense because we're all in the cloud, right? I don't have a single server in Mitiga. But that means that this is now a new vulnerability. And so this was GitLab, but there's so many from the last few years, right? So even when you look at Midnight Blizzard, that was the big campaign against Microsoft, China, supposedly, they targeted the source code. Why? Because if I get something into the source code, I can put malware in, but also if I have the source code, I find secrets, I find ways in. The GitLab server was used by over 5,300 documented attacks, right? And JetBrains, and then last year we had the Circle CI breach. That was big. Again, if you're a Circle CI customer, we woke up in the morning to this great notice of, oh, you have to rotate every secret you've ever used with Circle CI because we don't know the impact of this breach, but probably took a lot of secrets. And again, how do you hunt for that, right? And again, I can make 50 slides of this. So people are going after that. And so I want to walk you through how something like this happens, right? This is from an incident we did. And part of this happens by, again, compromising the credentials of your dev infrastructure, but some of it is by abusing other things, like misconfiguration. So a very popular misconfiguration in a Git is accidentally turning your code into public. Why does that happen? It's because, especially with GitHub, the repos, your developer, personal user, and work user are connected, right? If you've ever used GitHub. So you work on your work repos and on your public repos at the same time. And so one of two things we see happen. Either somebody just accidentally changes the permissions of a repo to public, or somebody pushes a piece of code to the wrong repo. Both things happen. Now, how long do you think it takes for a secret that's pushed to a public repo in GitHub to get discovered?
2 minutes.
Less. So anything between half a minute to 2 minutes, roughly, okay? There are scanners that run all the time and scan every check-in, every public repo. So if you put code on GitHub and it's public and there's a secret in it, you shouldn't even check if it was compromised. Just assume that it was compromised, and quickly, right? And so this is what we see here. So this is a customer where a developer accidentally didn't change the repo, but merges the code to his open source project that he was working on, had secrets in it, key obtained in minutes, and then luckily for our customer, there was a lot of automation about finding the key, checking that it's valid, and doing discovery. But then the exploitation at this point is still manual, and so they never got to it by the time that we're able to identify and block that. But we can already see, a bunch of these are all discovery events. So within minutes after the code was pushed, you can see in the logs, somebody read the code, used the secret, used an agent to verify that this secret is being, the secret was used, and then did all these things, okay? And again, that's not special. That's one example. We see that all the time. And again, looking at what happened in Sisense. Again, we don't know how their first account was breached, but one of those two ways. So what can we do, right? So we understand that this is the new attack vector. There's so many breaches here. And it basically means that we need to start treating our code to cloud infrastructure, the SaaS tooling that we use, right? The GitHubs, the Snowflakes, everything we use in this infrastructure, we need to start treating it like everything else that we do in security, which today we don't. Most of these services we just consume and assume a shared responsibility model. Somebody else is, GitHub is securing my code. No, it's on you. And so, we need to get in things like prevention. Why? Because that's how we do. Improve security. Make sure that you do all your settings. Get everything in place. Enforce MFA. Again, some vendors won't allow that. Tie things to single sign-on and enforce single sign-on. This is super important, by the way. When you turn on single sign-on for a SaaS app, which is what most of you do, the default is you do it for convenience, meaning people can do single sign-on from whatever you set, but it doesn't disable the non-single sign-on for these users. That's most SaaS applications. So they will let you live in duality, where you can use single sign-on, but still also use normal. By the way, Snowflake is that way too. Most SaaS vendors will allow you to force single sign-on, meaning once a user is defined with single sign-on, they can no longer use their regular user. It's usually not on by default. So you should make sure that it's on. And if it's something like Snowflake where you can't do it, then you should block it by putting crazy passwords that the users don't know. So prevention and then detection, which is really where most people don't do anything today for these services. How many people here have alerts on GitHub? Suspicious logins? 2, nice. It's better than most places I do this talk. So detection, start streaming your logs to a platform that can do detection. Your SIM, build your own rules, bring something that helps you, but start looking at these activities. And anomaly detection. Why? Because it's all legitimate access from a computer system perspective. And then response. Be able to respond, be able to investigate, be able to have those skills. Again, most teams, look at the Snowflake breach. Most teams we spoke with, they had no clue what to do at this point. They don't have the Snowflake logs. They're in Snowflake, again, in SQL. But even if they had them, they don't know what to look for. They don't know how a login looks there. One last thing from the IBM Cost of Data Breach report. IBM Cost of Data Breach report talks about impact of breaches, right? So I talk a lot about response, and the value of response is reducing impact. It doesn't reduce the likelihood of a breach, but it reduces impact. And there are 3 controls that contribute the most to reducing the impact of breaches, meaning once you already get breached, how bad it's going to be. 3. Those are by far bigger than any other control in this last year's report. And those are having a good DevSecOps. Why? Because it's all in the cloud, and if you have a good DevSecOps team, it means you can respond quickly. It means once you discover it, you're able to change setting, block things, reinstall things. Super important because time to respond is the single most important factor for breaches. Have an IR plan that is tested, have the team in place, have the way to conduct incident response. Again, if you don't have it, then once something hits, it can take you very long. Take you very long, you're compromised. And employee training. And why did employee training become so big? It's grown a lot since the years before because it's all about credentials. And employee training, to some extent, helps with credentials. You have to train your employees to secure their credentials, not to use them from insecure machines. And again, ideally, force that. We don't allow in Mitiga, for instance, logging in from any machine that's not a Mitiga onboarded managed machine. Yes, it's not an easy control to enforce. It's easy in in the small scale of a startup. But it's a huge control because one, the likelihood of credentials to get breached is smaller, and two, even if they get compromised, it doesn't help because you need a Mitiga machine to log in. And finally, if you want to hear more about why people should spend more in response, I'm doing another talk in 2 days in the crisis management event. So more than happy to see you there. So apply what you learned today. Map where your exposure is. Map your code to cloud exposure. Improve your posture. Start by that. I mean, some of this thing is really easy. Just look at your critical path, CI/CD, code to cloud, SaaS infrastructure, right? Use GitHub, GitLab, Circle CI, Snowflake, RDS, whatever you use, and just go and look at all the settings of the security and just start turning on everything. It's a good start. And then finally, start being proactive. Start looking at your logs. Start building and treating your code to cloud infrastructure like you treat your workloads and your servers. Get them to SIM. Get people to look at alerts. Get them protected. That's it. Questions? Thank you. One question.
Back to the cost slide. What is this number, the 3.4?
So,
PII?
no. So that's in millions. So that's the cost of a single breach. Sorry, that's the average cost of a breach for organizations that have this control well implemented, on the low, or don't have this control well implemented. So the average cost of data breach is about $4.5 million, 4.35, trending slowly up year after year. But then this shows what influences that. So people that have a good DevSecOps practice that took all of them, their average was about $1 million lower, right? Which is a lot. And so if you look at somebody that has all of these controls implemented, it's going to be even lower on average, of course, right? There's breaches have so many factors in them. Okay, thank you.